and a little dotted line, and then he would be right. Okay? So if you do it on an exam for us, and you can read it that way, give the, whatever you're going to do, give the grader a clue. So he just has to look and go, oh yeah, that's right, next. Right? So yes, that's exactly right. You do need to pay attention to that little tiny detail, that you're finding a tangency, and then you are just literally reading the coordinates of the tangency. That's all you're doing. I don't care where this hits, I don't care where that hits. It has nothing to do with anything. Right? All you're doing is you're finding the tangent bundle, and just like in 7th grade, you're mindlessly reading off its coordinates, and since we're beginning economics class, you can round things as you please, providing the, who's ever grading it can see you're being reasonable. That's it. That's all we're doing. So I will not be seeing this number or this number showing up. Is that right? Does it have anything to do with where the tangency is? No. What could I do with these numbers? They're interesting numbers. What could I do with them? Yeah, I could find the ratio of the prices from them, but that wasn't the question. Now let's go through a change in income. Now, before, I always forget I have a pen available to me here. So remember, you're getting a line is price wine, wine, plus price bread, bread. And I have bread on the axis, so I probably should solve it for bread equals y minus p wine, right? All over p bread. Right? I got that right, I hope. And so in terms of slope-intercept form for a line, when I change y, I'm not changing PW, I'm not changing PB. The only thing I'm changing is y. And the intercept is, of course, y over PB. And as a result, I'm going to create a line that is shifted parallel upwards when I give more income to the consumer. So original budget states the low, budget constraints the lower one, new budget constraints the upper one. I freehand drew in two tangencies. I mean, quite literally, if I said, draw for me the case where a consumer first has one income, and then, I can't hear my voice coming back. I can play with this if you don't mind. Maybe if I button the shirt, first thing I can die of heat exhaustion. Come on. One thing button. Let's see if that produces that sounds a little better. So I said, draw me the case where a consumer has first one income and then another, and show me his choices. You would say, okay, so I get myself an axis. I choose what I have on it. I have green beans and books today. I draw a budget constraint. It's a straight line. I draw a parallel budget constraint. It's higher up. It has more income. I take my chalk and I draw an indifference curve that's tangent. Remember, my indifference curves slope down. My indifference curves look like moons. I draw a higher indifference curve. I mark the two tangencies and I'm done. And that's exactly what we've done. It's not like there's anything that tells you how to draw these things other than draw them so they are downward sloping, not back upward sloping at the end. No. Downward sloping, and draw them so that the area above them is a convex set, or they look like hormones. Okay, so I got two, and take a look and see what happens. One of these goods is a normal good and one's an inferior good. What's a normal good? Income goes up and you buy more. Okay, and an inferior good, income goes up and you buy. And in this diagram, which good is inferior? Someone said bread, which is correct. Here, let's mark some tangencies. And then I'll just come over a little bit so you can see it, right? So as income went up, the quantity of bread went down, did it not? And that's an example of an inferior good. And what about, just for completeness, wine? What happens as income went up? Wine went up, right? Can both goods in a two-good world be inferior? No, but why? Prices have stayed the same. You got more money. Why can't you buy less of both goods? Why? Yeah? You'd be under your budget constraint. You have money left over, and then like somebody said, you'd want to buy more, and so you buy more of one of the goods, and you're gone. Yeah, you can't buy less of both goods. You have money left over, and the money can be used to buy one of the goods, and so you'll never do that. Yes, that's the story. So we now have inferior and normal, and now we can move on and create a theory of demand curves. So let's see what we can do. For demand curve, I want to change a price and see what happens. Again, my mantra from those bundles you can afford, choose the one that makes you happiest. And I give the budget constraint again, and I'm giving difference curves again. And here I have a worked out diagram, which I'm going to let you play with. I have three lines, a red, a blue, and a green. I have an additional piece of information. The price of wine is 1. And what I want to know from you is what's the price of bread on the red curve, on the blue curve, and on the green curve. And you've got 3 or 4 minutes to do that. So go for it. Hey, it's better to do these things in class than on exam for the first time, right? So what are the things that I always emphasize you want to write down? The intersections are y divided by a price. So it's easy enough to look at income divided by the price of wine is 80 in all the cases. Now write down income divided by the price of bread for the 3 cases. First, I'd find out income if I were you. Right? So you have a fact. Y divided by PW is 80. That's what the thing says. You're on a line. The line hits the axis. Where does the line hit the axis? At Y over PW. You spent all your money on wine. So the amount of wine times PW equals your income. Therefore, you should be able to find your income very quickly, because the price of wine is what? 1. So go find the income. That should not be hard. Now, we're going to use the same kind of fact again. Come down here. Let's do the blue line first. What are these things? 10, 20, 30, 40, 50. So that's 40. Yep. That's 40. So what do you know? Do you know income? Yes. Right, because it's the same on all 3 lines. So you know income. You know that the blue line hits at 40. You know the line hits at the point where you spent all your money on bread. So the price of bread, which you do not know, times the quantity of bread, which you can read off the graph, which is what? 40, equals income, which you already read off the graph and is what? 80. And so you should be able to tell me that unknown price. Yeah, exactly. Now, do that again for the red line, and do that again for the green line. And then you will have it. And forever after, you'll be able to solve these small puzzles. And by the way, if you don't get it and the person next to you has it, in my class, the etiquette is by all means ask them, or tell them, whatever helps. You know, if I want you to be quiet, I have a loud voice, I'll tell you to shut up. If you don't see it, the person next to you does see it, As they'd say, talk among yourselves. But I want 3 prices in about 4 minutes from now. Yeah, you're all with me? Okay. Any magic there, or it's okay? So now we want to keep a little chart. And what I want you to do is I want you to make up a chart where you have, and it'll be easier to do it this way. We're going to have a quantity of bread. I guess we should just call that B. We're going to have the price of bread. And you already have some prices, right? You have a price of, what are they, 1, 2, and 4? Right? And now I'm going to want to get the quantities of bread and finish off my chart. So when the price of bread is 1, right, I'm on green. Where is the tangency on the green in terms of the number of pieces of bread? Anyone disagree with 40? Does everyone see where we got 40 from? Anyone doesn't see where we got it from? All right, so write down 40. So with the price of 1, you have 40. You keep a running tab. I won't. With the price of 2, how much bread? Someone, whoever calls it out gets the answer. That's the way it works here. So this is 10, 20, 30. It's clearly going for 35. I heard 35, sold. You think that tangency is at 35? 25? Did I get it wrong? 10, 20, I'm sorry, 25. Okay, sold. Unsold and resold, 25. So when the price is 2, your chart should have 25. And now we have the high price. The price is 4. And how much bread do we have? 10, right? So everybody's with me? Everyone has one of these charts now? You should have 6 numbers on your chart. 1, 2, 4. 4 goes with 10. 2 goes with, what was it, 25? And 1 goes with 40. Are you clear on where we got the chart from? So let me give you a standard test question that I tend to ask. Draw me a picture with budget constraints and indifference curves and use it to show where you would get 2 points on a demand curve. Right? And that's what we created. We created 3 points. I created for a price of 1, what's the demand? It's the number on your chart. The price is 1, your demand is 40. The price is 2, the demand is 25. And the price is 3, the demand is 10. You have 3 points on a demand curve. Yes? How would I ask the question? I'm very open-ended. Draw me a picture with budget constraints and indifference curves and use it to explain to me where I would get 2 points on a demand curve. So you wouldn't have to draw 3, you only have to draw 2. And you would presumably make the same kind of choices I do. You choose the price of the thing on the vertical axis to be 1 because it makes your life easy, and I haven't prevented you from doing it. And then you draw 2 of these things, and you put whatever is convenient here, here, and there, so your prices work out even. Right? And then you draw in by eye the 2 tangencies and draw little tiny curves down and read them off. And you'd be done. And I might make you explain some. What did you do? And then you draw the diagram, and you write me sort of a paragraph that explained, this is what I did. And short declarative sentences work fine. I drew 2 budget constraints. They both start at 80. One of them ends at 40, and the other ends at 80. I have chosen the price of wine to be 1 so that my income is also 80. Therefore, using y over the intercept on the horizontal axis equals y over the price equals the intercept, I find that the prices on these 2 lines are 2 and 4. I have now drawn 2 indifference curves tangent to my 2 budget constraints, and I read off the quantity of bread that goes with each, and it's this and that, and my chart below shows the 2 points on my demand curve. Thank you. Right? Keep it simple. So I make the chart. I went for 22. Obviously, went for 25, just fine. And then I just plotted them. Plotted the price of bread and the quantity of bread. And then I took my pen and I connected them up. And that's, for our purposes, how you get a demand curve from people's preferences and people's budget constraints. That's our story. The last problem that you have to do asks you to think about that process. It's not nearly as complicated as this. What you need to know, since you only have 1 night to do it, is that there are a lot of things that could move around. The things we normally move around are the price lines. We give you income. We make the price lower. We make the price higher. We make the price some complicated thing where you get 2 for a cheap price and 1 for an expensive price, or the other way around, right? That's what we tend to do. And what I ask you to do in the problem is think about environmental education. What does that change? So think about a good that's some environmental good. How many disposable water bottles do you buy? How many people believe disposable water bottles are evil? I didn't used to believe it, but I come around. So you have some environmental good, and somebody is going to hold up their big metal water bottle, and they'll explain to me why you don't drink from. Excuse me, can I embarrass you a little bit? Thank you. So why wouldn't I drink from this? Why? Because your kids will have 3 heads. Because you got all this plastic in you, maybe. Because you actually can't control them after they go out of your hands because they're lightweight. And so what happens is that somewhere in the process between you and they're getting landfilled, they get lost and they end up in the ocean, or they end up in Africa. They end up being blown onto the land and they strangle animals and stuff. Man, horrible outcomes. But you should think about your kids having 3 heads when you drink out of plastic. All right. So we've got a little bit of environmental education, and now, magically, tomorrow she comes back with the water bottle made out of metal. No more plastic water bottles. Did the prices change? No. Did her income change? No. So what's left to change in this story? Okay, and now you can easily do problem 4. And I got my rant in on water bottles. And I have a real paper on water bottles. I can tell you that taxing them at 10% only gives you a reduction in the quantity sold of between 3 and 10%. And someday you can ask me about that, and I'll spin out how I would find that. It's an interesting story. So we got demand, and our problem sets are now done. How many people have already done the problem set? Well, am I correct that one of those problems took you some time and you had to sit there and think about it a bit? For those who did it? Or is it just like totally easy and was all done in a minute? Tell the truth. It'll help the others. It took a little time, did it not? One of them? Yeah. One of them takes a little time. You have to think about it. So don't try to do this Thursday morning. You will not be able to, and you'll be frustrated because it's not like there's lots of computation, but there is some thinking, and it wouldn't hurt you to have a good friend who's in the class who's also thinking about it and bounce your ideas off them. 3 of them I think are just doable by yourself without thinking, but one of them I believe will take you a little bit of thought. I don't believe it's going to take you a lot to write up, but it's going to take a little bit of thought. Is that fair? Yeah, they say it's fair and they've done it. You're looking at me like, what's about to happen to me? Okay. Here I've made the same diagram, and I did one more thing. I said, what would happen if I increase income? And if you went back to the increased income things and you think it's a normal good, what happens if I kept the prices the same? So I kept the price at, here I have a price of 2 apparently, and when the price was 2, I was buying 24 units, here it's clear it's 24, and then I gave them more income. What happens? It's a normal good. What's it going to do? Not going to have this point anymore. Where's it going to go? It's going to go out. I picked an arbitrary point, obviously. Is this point on this demand curve? No. It's on a demand curve that shifted out because this thing's a normal good. So that's what would happen to your demand curve if you added income. Normal good would shift out. Here's an example from the book Electricity. What's the electricity demand? And for the example, I'm going to make an assumption it's not too terrible, that there's a flat supply curve. There are roughly 1 million households in the place that was studied, which is Montana. And what I want to know is how much tax revenue would you get for a $50 tax increase, which is a lot, and how much electricity gets saved. And if you want some idea of scale to this, you have to do some things yourself. You have to figure out how big Montana's budget is. That would be an interesting number. How much carbon per megawatt hour, assuming coal, which I assure you is what they're burning to get their electricity, and how much does carbon sell for on the European trading system, which is about, these days I think it's only about $10 a ton. So you might want to, if you want to really finish this up and turn yourself into an environmentalist, you should certainly answer these 2 questions after we get done. And if you want to be a reasonable policy analyst, you better know that number. Now let's see what we got. Here's the original price budget constraint, and that is $50 a megawatt hour, and this is very close to the real numbers. So my friend Jeff LaFrance was asked by the Montana Public Utilities Commission to estimate the demand for power in Montana. And I went and found the report he did, and the examples in the book are actually based on the numbers Jeff found. This is not fiction. I made things a little straighter, and when you'll discover I did a little stuff to give us 50 even and not 49.77, but really we are very close to the real numbers here. So I have an original budget constraint. My original budget constraint is between 2 things, one of which I call stuff. That's all other goods. This is everything else. And the other is electricity purchased. I have an original price of 50, and I have a household income that you would think is quite small. It's like 10K, but again, I think that's about right. And you'd have to read the text to make sure I got my details right when I did this. Here I have found the chosen bundle, and this is the indifference curves here really come from empirical work Jeff did. These are the indifference curves that will get you the right choices with his empirical work. And so you find out that originally they were taking about 2.6 megawatt hours, I believe, per year per household. And when you double the price, so if you put a tax on electricity of 100%, doubled it, you come down to 1.81. So how much play is that in terms of carbon? So you could go out and you could look up, if I save 0.8 megawatt hours per household, if I got this right, times 1 million households, if I got it all right, and I bollocks it terribly, how much carbon saved is that? How much is that carbon worth? You could literally go and answer that question. But notice, doubling this doesn't drive this to 0. Doubling this makes a difference. It's not nothing. It's like a quarter. But you're getting a double in price for only a quarter change in quantity. That's not a huge elasticity. And so here's the demand curve. Again, I just used the 2 points. And here, it's a curve in between. I actually know what the curve is. This is not hand-drawn. This is actually accurate to the research. And here's your 1.81 again.